I'm Sheila Jasanoff. I'm professor of science and public policy at the Harvard Kennedy School, which is Harvard School of Government. And the field that I work in is called Science and Technology Studies. It's the broad theoretical exploration of the ways in which science and technology relate to the rest of society, going in both directions. So it addresses questions about how what happens in science and technology has implications for whatever else goes on in society, but equally it asks questions about how the things that we do in society, how we organize ourselves, what kinds of needs and desires we have, how those feed back into affecting the kinds of science and technology we do. So the International Panel on Social Progress was imagined as a large interdisciplinary study that in some sense asks how the social sciences are contributing to this very fuzzy but broad gauge thing that we all want to know about, social progress. And some of my colleagues in my field of science and technology studies, which I will refer to as STS from here on out, so how people in STS could advance our understanding of the kinds of topics that the IPSP would be dealing with across the board. So these colleagues, who are major figures in scientific research organization in Europe, approached me to be part of a team of STS scholars, and our job, as I understand it, is in part to look at all the huge variety of topics that the IPSP will be addressing and make sure that some dimensions of what we know about science and technology are incorporated into our understanding of those other chapters and topics as well. So, there will be things about social justice. So how does STS have any contribution to make to social justice? Or explorations of culture. Does STS work have any bearing on our understanding of culture? So in that sense, it's a little bit unusual. It's not delimited to a very specific chapter, though I think there's a chapter that's going to be about STS towards the very end of the collection as it's imagined, but it's also a sort of cross-cutting look to make sure that the kinds of understandings we have about science and technology are included throughout this compendium that's going to be produced. To me, the invitation was very appropriate and timely, and let me give you an analogy in a sense. The person, my colleague Johann Schott, who's the director of the Science Policy Research Center at the University of Sussex, said that IPSP was being modeled in a sense on the Intergovernmental Panel on Climate Change reports on climate change. So that intergovernmental panel has been operating for some years trying to pull together what the state of the art is in knowledge about climate change. So a number of years ago, other colleagues of mine said, well, the IPCC, the Intergovernmental Panel on Climate Change, is pulling together knowledge on the natural science side of things. What about the social science knowledge that is also relevant to climate change? And I was approached at that time to say, well, here we are writing about expertise, we're writing about social expertise on society, but STS is the field that studies expertise in and of itself. So how does STS even frame these issues about knowledge? And I wrote, together with some colleagues, a very large introductory chapter for that collection. So I saw this as very much continuous with work that I had already been doing, asking a very foundational question. And that foundational question is, how does what we know about knowledge factor into the kinds of things that we know about everything else? So I see my role as partly doing what I've always been doing, promoting my field to be more relevant, more central to the ways in which we think about society and foundational questions like social progress, but at the same time also an interesting new challenge because it's trying to bring STS into conversation with other fields where it hasn't been in continuous conversation before. I think to some extent, from my very earliest research projects, I've been interested in phenomena of change. For one thing, my field got going studying controversies. So one of the points of origin of STS, particularly in North America, less so in Europe, was around the big technological controversies of the 1960s and especially 1970s. 1970s was the decade when this field of STS came into being as a definable thing. And the 1970s were filled with controversies. There were controversies about chemicals and chemical pollution and the use of pesticides. There were wide-ranging controversies over nuclear power. There were controversies about building new urban structures, about renovation and restoration, about military technologies and what we should be doing about them, about assaults on privacy, about secrecy, about the ethics of research with human beings. I mean, wherever you looked, wherever the frontiers of science and technology were advancing, and that was like everywhere, there were also controversies. But you can think of those controversies not just as time-bound controversies, but as being about what human beings want their futures to be. So what kinds of futures are we imagining? In that sense, I think controversies was always a part of trying to understand the phenomenon of change. How fast should it be? What are the directions it should be going in? Are there places where we should actually stand back and say, thank you, no, we don't want change? If change was going to occur, how should we address the problems of inequality? Because it's been understood for a very long time that the more resources you have, the more capable you are of bringing about change. But that gives a one-sided advantage to dynamic societies over more stable and static societies, and so forth. So I think that the field and my own work in it from the very beginning were very concerned with issues of change. But I've now been in this field for my working life, and I've helped make it in certain ways. So how I think about it and how I think of my own work within it has also changed. So two directions in which I think about change may be worth mentioning. My most recent work is about the imagination. So I'm interested in how collective imaginations come about. And going back to what I was saying, it's collective imaginations about what sorts of futures we actually want to live in. Much of my work on biotechnology, life sciences and technologies is related very closely to questions about what do we think life itself ought to be? To what extent ought we to be able to manipulate it, make it more machine-like, make it more standardized, make it easier to control? Those are all questions about change, looking to the future, and my body of work on biotechnology, particularly genetics and law, relate very closely to that set of ideas under the theoretical idea of imaginaries, collectively held social beliefs about the future. The other thing I'm interested in is, in a way, the flip side. So how do we establish what shouldn't change? And there, my training in law plays a pretty central role, because I'm very much taken with the idea of constitutions as documents or as resources with which we think about what should remain stable in the structure of our society. So if you think of the American Constitution, for instance, we're operating with a Bill of Rights that's more than a couple of hundred years old, but we still act like those provisions can tell us how to deal with extremely new technologies. We can be dealing with the privacy of cell phones, for instance, an issue that was just decided by the US Supreme Court very recently about whether the police can go in there and search your cell phone. The answer is no, not without a warrant. But in any case, that's not an issue that Thomas Jefferson thought about or Benjamin Franklin thought about. Those are issues that we're still deciding today using conceptual ideas that are hundreds of years old. So I think that in my work, the playing around with the idea of constitutions is one place where I think about stability, which to me is the flip side of change. So you're asking what the most relevant social problem is. I mean, to some extent, the boast of a field that looks at science and technology is that it's universally relevant and across the board. So I'm not quite sure whether you think about what the problem is for the field itself in addressing social problems, or whether you think that, or whether you're asking what should we in STS, which social problems should we direct our attention to? I think the second question, what should STS scholars be thinking about? Which problems should we direct our attention to? They're not so very different from what other social sciences would say. I think we may have a particular interest in problems that have a large technological dimension. So peace, war and peace, for instance, where our capacity to make war and to make peace are so tied up with the technological commitments we make. So ideas about what will the discovery and further development of drones mean to international relations, that would be a kind of important central set of issues. Similarly, environmental sustainability, because sustainability is going to relate so closely to technological developments. So I think all of the questions around long-term environmental change, biodiversity, climate change, of course, but also the more invisible kinds of processes that relate to population density, to the survival of particular kind of niche species and so on and so forth. These are all, I think, particularly important social problems from an STS point of view. I do want to say a word about the other problem, which is for the discipline as a whole, are there intellectual challenges? Because I think that we, in the field of STS, there's a particular set of challenges because we're actually questioning the nature of scientific knowledge itself. And that science has acquired such a sacred status that if you start asking destabilizing questions like, what is a fact and how do we actually know what we know, that can cause a lot of uneasiness in other domains of the social and the natural sciences, where people want to be able to hold on to something and say, hold on a minute, we know this to be true, and you can't start asking questions, where did that knowledge come from? So in that sense, STS, I think, as a social science, faces a particular set of problems because we are actually questioning to some extent, how does stable knowledge gain its own stability? Based on my long experience of working across disciplinary boundaries and working with people interested in other sorts of issues, I think that one potentially enormous value of such an exercise, certainly for my field, but maybe for all the participants, is that it may enlarge the set of questions that we think are relevant to be asking, and it may give us new insights into kinds of problems that we didn't think about investigating before. So to some degree, my own research has moved by taking on things that other fields are discussing and then seeing if there's some kind of orthogonal or different perspective that we can bring to bear on it. To some degree, this is something that happens naturally, that people follow where the issues are hottest. So this year it's inequality, next year it's sustainability, last year it was poverty, whatever. And, so fields change a little bit by that. But I firmly believe that our conversations about what is worth inquiring into change by talking to people in neighboring disciplines. So I'm quite hopeful that the kind of mix of very high-level, intense disciplinary discussions that are brought together under this umbrella will produce new ways of looking at things. That reframing, I think, is the most important thing, but then also possibly new methods and approaches to looking at those things as well. The role of science in law that you're asking about is my core interest and preoccupation since very early days, though I never knew that that was what I was going to get into when I first started studying law. I had finished a humanities PhD and was confronting the two-career problem and decided that I would go to law school to get practical training in something, but then through various accidents, I ended up becoming an academic anyway. And since some of my earliest work, I've been thinking about that relationship between science and law. The starting point, I think, for my thinking is that these are the two most important institutions in society for making order. Science makes order of facts, law makes order of ethics, norms, values. And so how each one uses the other, relies on the other, disavows the other, these are phenomena of enormous interest to me. By now, I've worked in a lot of different topical areas, and each one opens up a set of somewhat different questions about law-science interactions. So some of my work is comparative across countries, and there, if you look at the ways in which legal systems deal with scientific knowledge, technological developments, you find that there's quite a lot of disparity. And you might not expect it in the first place. In my very first research project, for instance, I looked at the ways in which cancer-causing chemicals were regulated in 4 Western industrial countries. And the expectation was, for a lot of people, that there wouldn't be very many differences. After all, nobody wants cancer, everybody wants to make sure chemicals are safe, so why should there be differences? But we discovered that there were differences, and so it arose as a question, what is it about legal systems and legal processes and procedures that help us explain why people confronted with the same facts will not make the same judgments? In later work, I've used those kinds of comparisons to dig more deeply at the foundations of both legal understandings and scientific understandings. So in my most recent work, what I'm interested in is the ways in which our preferences as societies about how we should go about knowing things are related to our understandings of how we should organize ourselves as good societies, just societies, and so forth. So coming back to the SP in the IPSP title, I don't think one can talk about social progress without talking about both science and law, and how the ideas of each, plus the interactive ideas that each has about the other, how these operate to create our very understandings of progress, of society. That's what I see as my current sort of wide domain of thinking about law and science. Okay, so you're wondering what I would have to say about the relationship between science and politics and public policy, and maybe more specifically about climate change, where there is this puzzle that at least people in the US don't seem to agree that climate change has been securely established as a scientific fact. We're talking in the Kennedy School, and the Kennedy School's first director was a man named Don Price. He was a political scientist, and his research field was the relationship between science and public policy. One thing that's historically interesting to me is that what Don Price thought was a problem back in the 1960s, few of my colleagues think it's a problem today. They think it's obvious what the right relationship between science and public policy ought to be, that science gives us facts, these have to be inputted into public policy should pay attention to the facts, and make rational decisions, taking account of other factors as well, such as economic costs and the distribution of benefits, and so on and so forth. So I think that the first thing that I want to say in my own work is that is an overly simple understanding of the situation. That science doesn't simply give us facts. For one thing, these days, scientific knowledge is much more about how should we understand uncertainty and not what is a fact. We're not usually talking in the public policy domain about questions that are even as cut and dried as what is the structure of DNA. Even then, there can be some questions about those things. We're usually asking about much more broad-gauged questions, like if the climate changes, but within a span of degrees that's already quite large, then how should we, as societies, as localities, as regions, be responding? the city of Boston, for instance, was situated near water. What degree of precaution or what degree of care should we be taking as we go about, for instance, doing riverside or seaside development? Harvard is renovating its undergraduate dormitories after a very long period of stagnation. But the question is, what standard should we be even renovating to? What will the climate be? How much air conditioning should we install? So there are very mundane local decisions that depend on science being able to tell us about quite distant futures. The more distant you go into the future, the less certainty is and the less knowledge there is about, how things will be. Even locally speaking, we have just come out of one of the worst recorded winters in Boston history, setting all kinds of records for snowfall. Is that going to be the new normal? Some colleagues of mine were talking about what material they should use to re-roof their houses the next time that they put a roof on their houses. So public policy questions, individual policy decisions are often founded on a state of knowledge which is shifting, which is uncertain, and which cannot deal with the full complexities of all the factors that we ought to know. So I think we need a much more complex set of understandings about the relationship between knowledge and policy and politics. My own view is that we have to pay a lot more attention to the process by which we make use of the knowledge that we have, and that includes the processes by which we generate the knowledge itself. So part of the work that I do and part of the work that others in my field do is actually look at the institutions that are responsible for producing knowledge for public policy. So back in 1990, I wrote what is my most cited work and certainly one of my most influential works, and that is called The Fifth Branch. It's a study of advisory committees. So until I wrote that book, people hadn't really grappled with the fact that science used for public policy, which I called regulatory science in that book, that science used for public policy is a different type of thing from the kind of science we're producing at the bench. So this just is to give you an idea that once you get away from what science policy experts call the linear model, that is, you first find the facts first, plug them into something called policy, get answers, and then carry it out. Once you get away from that linear vision, there's a whole complex of questions that opens up. And to me, those are mostly questions about politics and ethics. They're questions about process, they're questions about inclusion and exclusion, who should be at the table. They're questions about what appeal there is if people get it wrong. They're questions about responsibility, where we cannot know, then what is our responsibility? And there are all kinds of situations where we simply can't know, even if we have the capacity to ask the right questions. Challenges of science and globalization. It's a very intriguing area to think about from a legal and political point of view, because science has been such an important instrument of globalization, even a model for a certain kind of globalization. So scientists have, of course, claimed with a lot of justice that the facts they find are not local. That is, if you discover something about a basic scientific phenomenon, it's not going to matter whether you discovered it in South Africa or whether you discovered it in China or whether you discovered it in Canada. It should be the same fact. And so scientists have for a long time seen themselves as in the business of producing universality. What science says should be heeded by everybody around the world. It should be the foundation for making policy. Science, in that respect, sees itself as a kind of engine of globalization, and technology follows closely after. So if we decide, for instance, that we're going to invest in renewable sources of energy, there are only so many sources we can harness, and there may be small differences in the ways in which solar panels would be manufactured or wind turbines would be manufactured, but the technologies will be roughly the same. That is, we'll have windmills to harness the wind and solar panels to harness the sun's rays and warmth. So science and technology have looked on themselves quite unproblematically as the frontiers of globalization. Scientists themselves move around from each other's labs all around the world, and they kind of think that they carry a universal passport. The challenge is that when the technologies touch down, and even when the facts themselves touch down in different parts of the world, there are differences across localities and regions. And sometimes those differences are big enough and important enough that they create friction. So take something very profoundly contested right now, which is how much genetic modification should we have in agriculture? The genetic modification itself can be a universal issue in the sense that we understand how the corn plant grows and what its components are and how the rice plant grows and so forth. But what exactly you should be tinkering with and for what purpose will not necessarily be universal at all. So you may want a high yield in one place and drought resistance in another place. But who will determine what the science is that we ought to be studying? Even though the technological development itself may be recognizably the same everywhere, that is, we've taken a plant and we've modified a particular piece of its genome to have some properties, the way that plant is introduced into different agricultural contexts may make for huge differences, particularly from the standpoint of social progress. So in a country with very large agribusiness, with a lot of capital, the ability to guard against risk and so on, the use of that same technology may be in some respects easier, certainly less problematic, than in a country where people are growing things in just to support their livelihood from season to season, and where they don't have huge reserves of capital if something fails. And you know, as both of us know, the idea that technologies always fail, you know, we all know it at the individual level, but when we're introducing novel technologies to push social progress, we sometimes tend to lose sight of that fact. Yeah, so let's talk about the public's trust in science. I find this question about whether the public trusts science or not a little bit paradoxical. I mean, I find it paradoxical that people keep raising it as an issue. Pretty much all the survey data show that if you just straight out ask publics, do you trust science, there's a pretty high degree of trust in science across the board. So when you come to specific areas like, do you trust the science related to genetic modification of plants, or do you trust the science of climate change, sometimes you hear a different set of results. And I think it's because science is understood differently in those two contexts. I think people have a lot of faith that if you do science in accordance with sensible scientific method, that you have rigorous procedures for gathering data, you make sure that confounding variables are excluded, that you interpret the data using the right kind of mathematics and statistics and so forth, that it is the best and most accurate way to go about finding out knowledge. But then science is also a social institution. These days, you cannot do science without an enormous amount of money. You couldn't run even a modest lab without having things like $1 million a year to run it with. So that money has to come from somewhere. And over the last half century, we've gradually moved from a situation where universities could support their own scientists and fund their own scientists to some degree, to a situation where we're relying heavily on interested parties to fund the science. Now, those interested parties can be in government. It can be government desires for the better weapon or the better solar technology or what have you. Or it can be the private sector that wants the science to do its bidding by finding out how to make new biofuels, for instance, or other things, or pharmaceuticals and medical drugs. So where there are those interests involved in funding science, combined with science's own appetite to continue to do the inquiry, people have lost faith that scientists can maintain their neutrality when they're pressed into service to find particular solutions to particular problems. I think in areas, the very contested areas, like are vaccines safe, or is drinking water safe, or is climate change occurring in a predictable way so that we can decide what kinds of improvements we'll make in our houses or how we will renovate our streets in our town. In all of those areas, I think you find a lot of distrust because people see that so many consequences are riding on the answers to the questions that the neutrality of science has become, to some extent, a myth. One of the things that I've been saying about STS for some time is that it's a surprising gap in the array of social science fields that we teach and that we support at major universities throughout the world. There are very few universities that have doctoral training programs, dedicated research programs, departments, institutional infrastructures that support the critical, rigorous study of science and technology and their relations with society. And this strikes me as a puzzle, and it strikes me as something that a project of this sort could raise to greater visibility. One of the ways that I put it is that throughout the university, we have departments that are studying different forms of human creativity. So we communicate and use media, and there are departments that study the media and our relationship with it and how we report on the world and so forth. We make art and we make sculpture, and there are departments dedicated to the study of those things. We are political animals as human beings. We organize ourselves, we contest each other, we make decisions that empower some people and disempower others. We form social groupings. We have departments of sociology, we have departments of political science that go about studying those particular forms of human creativity. So we do science and technology. I mean, if there's one way in which we are different, majorly different from the way societies were 200 years ago, it is that we could not move around without science and technology. Even as you and I are sitting here having this interview, I see car after car and SUV after SUV and truck after truck driving down the road and out of Cambridge. Well, what are all those people doing? How did they come here? They couldn't live their lives from day to day if they didn't have those technologies. And yet in our thinking about the social sciences, we haven't really devoted much attention to creating a systematic, rigorous field that is studying this particular form of creativity. So I think that that is a very interesting moment to be in, and I'm very much hoping that STS's engagement with the IPSP project will help the field to define itself better in the whole territory of the social sciences, but also to have more impact in thinking about social progress. I sometimes think that social progress is almost a monopoly of STS because you cannot imagine progress without science and technology.